Hello all, and welcome to API 302, GraphQL, building a consistent approach for the API consumer. My name is Dave Feuer, the head of global platform strategy at Apigee, a part of Google Cloud Platform, and I'm joined today by Miguel Mendoza, a lead architect at Apigee, a part of Google Cloud Platform. Today we're going to go over what is GraphQL, what it's good for, and what are some of the expected features that are missing from GraphQL. Secondly, we're going to go over consistency. What's the point of consistency, and walk through a REST best practices, and then translating that to GraphQL. Lastly, Miguel Mendoza is going to do a demo for us of how we would implement some of this on top of Apigee. The first thing I'd like to say is that GraphQL is awesome. GraphQL has some terrific benefits. And if I had to break down some of these benefits, I would break them down to three key areas. The fact that there's a single endpoint, so all the data is exchanged reporting a single endpoint, so granularity for data load and execution of requests in parallel, query planning, all of that is super straightforward in GraphQL. The second is an incredibly powerful query language that prevents overfetching and underfetching of data, as opposed to, let's say, in REST, where many of the requests have to be sequential. And then lastly, GraphQL client libraries. So GraphQL is no longer only the domain of the React.js UI framework, but it's also available for other client libraries and for other languages and paradigms, so that GraphQL is truly useful to most developers today. So why isn't GraphQL everywhere? I think ultimately this comes down to a bifurcation that we're seeing in the market. The first is that developer programs are frequently separated from API programs. Developer programs tend to be external facing or internal facing between business units, so that the author of the server and client are different. In APIs, frequently what we see is that the author of the client and server are a tight-knit group of people or the same person, and that's where we're seeing more of GraphQL. And I think part of that has to do with consistency, and we'll talk about that today. But fundamentally, self-service developer programs are a growth strategy. And so developer programs are a way of getting internal, partner, and external developers leveraging your APIs, as opposed to API programs, which are typically an infrastructure strategy, driving interoperability and decomposition of your internal infrastructure. So what are the benefits of GraphQL? Why use GraphQL? Well, we talked a little bit about some of the differences. Let's do a little bit of a deep dive, right? REST has multiple different endpoints and a URL taxonomy that's used as a logical resource manager for different types of APIs. In GraphQL, there's really one endpoint, and longer and larger queries for customer data encapsulate all the different value propositions that you would normally see in those different URLs in REST. In interactions, REST uses HTTP verbs and generally uses JSON and XML in order to exchange the data. In GraphQL uses POST most of the time, and also leverages different query types specified inside the protocol, not in HTTP. So there's no verbs, they're just a custom query language called schema definition language. So even though it's a custom query language on the request, JSON is returned, which makes it much easier for clients, but there's a significant difference in the interaction mechanism. Documentation is different, where there's OpenAPI specs and portals on the REST side. Really, in GraphQL, there's a schema-generated documentation. Frequently, we'll see customers using Graphical or GraphQL Playground in order to interact with schema-based GraphQL endpoints. And then, of course, from a discovery perspective, the portal is the playground in REST where a customer would normally go, or a developer would normally go, to discover and interact with REST APIs in order to understand how they work. In GraphQL, the portal actually is a built-in playground that accommodates development. It's almost like a built-in IDE, and so it allows you to explore new queries on the fly and use things like tab completion in order to discover those queries and in order to learn how to use them better. And so we're not here to talk about whether you should use GraphQL or REST. Our philosophy is that you should use GraphQL and REST. And I think one of the best ways to do that is to take some of our REST-based practices and apply them to GraphQL. This is something that we've seen in the market. This is something that we really see working really well at a number of customers, and so we wanted to bring those to you so that you could leverage them and understand what those are. The basis of this philosophy is that APIs are digital products. APIs are a way for an enterprise to take its assets and put it in the hands of developers, whether those developers are internal employees, partners, or external customers, in order to grow the company's leverage of those assets. Because APIs are digital products, we rely on developers having a consistent experience in order to understand how to use those digital products and build the compelling experiences they need in order to bring your assets to market. And so consistency is incredibly important because developer friction is a huge challenge in adoption of APIs and in growth strategies of digital companies. Consistency in GraphQL really starts with well-formed GraphQL. And I think we can learn a lot about that from well-formed REST. You would never expect a well-formed REST query to be list employees by department. That sounds like a Java function. A well-formed REST query would be a resource, right? Get employees, and you pass employees ID. And so that is what we consider well-formed REST, right? Nouns, and those nouns are plural. Graph hierarchy is fundamentally a data-driven hierarchy, right? So why do we frequently treat it like a functional hierarchy? Well-formed GraphQL shouldn't look like the Java functions, which it frequently does. Well-formed GraphQL should look like well-formed REST. Why not use books and titles and authors and treat this graphical hierarchy the way it should be treated as opposed to treating it as a functional hierarchy? And so the first recommendation we have is that you should be data-oriented. A graph hierarchy is fundamentally a data-driven hierarchy. Be data-driven. Treat it that way. Don't be so function-oriented. The second recommendation has to do with submitting and retrieving data. Those are not always mirrored operations. We frequently see in REST leverage of CQRS, right? We see retrieving data from multiple services in a microservice architecture being completely separate from how to submit that data. And so as we think about how to do this in GraphQL, we specifically think that mutations, the way a GraphQL developer submits data, can get very complex very quickly, especially when there's a lot of different types, and especially when submitting very little data. And so don't be afraid of CQRS. Many of you have heard of CQRS, which is Command Query Responsibility Segregation. It's a design pattern that was first identified by Martin Feuer. And fundamentally, it's just a different model to update information than the model you use to read information. And so what we're seeing in GraphQL programs, especially in large enterprises, especially those enterprises that already have REST, is that you get the advantage of using a REST-based front end by retrieving the data with GraphQL, but leveraging your existing REST APIs in order to submit that data to your backend. The third pattern I'd like to talk about is optimizing for reusability. You know, in REST, we think a lot about our URL taxonomy, pagination, filtering, and creating consistency because developers can then predict what the behavior will be of an API call. A developer sees the REST API and goes, aha, I know how to interact with this. Well, in GraphQL, we should be doing the same thing. The challenge in large enterprise GraphQL deployments is that when it comes to schema stitching, frequently different business units, different lines of business are developing different aspects of the schema and then stitching that together in order to look like one comprehensive representation, one big graph to hand to an external developer. The behavior of the JSON return, though, is frequently different because there's no consistency. It wasn't built as an API product, as part of a developer program. It was built as an internal API, sort of a functional way of interacting between components. So when we think about relay cursor connections and input hints, all the uniform behavior that you would expect in a REST API should also exist in the GraphQL API. So in GraphQL, we should be very careful about optimizing for reusability and avoiding situations where the developer is confused or otherwise doesn't understand why the behavior is different in one part of the schema than it is in another part of the schema. And this is particularly a problem with mutations because if you submit data to one part of the schema one way and it gets recorded one way, you don't always realize that when you submit it in another part of the schema, it got recorded another way. So mutations are even a larger surface area of challenges when it comes to optimizing for reusability and API productization. And so be particularly afraid there, be particularly conscientious of the way you develop and design mutations in GraphQL. Lastly, I want to talk about field names because this is something that Miguel and I have experienced personally. It is developer hostile to provide different data and behavior for field names with the same name in different parts of the schema. So if there is a name field in one part of the schema that accepts first, middle, last name, and then there's a name field in another part of the schema that expects last name dot first name, that is developer hostile. You are not treating your developers the way they expect to be the way they expect to be treated, and your developers will frequently experience developer abandonment because your developers will struggle to adopt your GraphQL API. So avoid the GraphQL anti-patterns. Treat the graph as a data-driven hierarchy. Don't force GraphQL. Use REST where and when it makes sense. And lastly, optimize for reusability. Think about API products, think about the developer experience and treating the developer as the customer they are, because you want your GraphQL API to be used and you want it to get to market. There are challenges in GraphQL deployments, and I'm going to go over these challenges very quickly because I think we're all somewhat familiar with them. AuthNZ, authorization authentication, is a huge challenge. As you know, the GraphQL spec delegates AuthNZ to the business logic layer, which means that it's typically not handled by the GraphQL server. Throttling is a challenge. There's no standard like we see in API productization for creating different levels and different tiers of service and different access to different API developers. The third is analytics. There's no unified view of analytics, which means leveraging APIs as products, raising APIs to the level of business analytics as opposed to just operational metrics is not something that's possible. And lastly, versioning ops. We don't understand how versioning works in GraphQL and how particularly to address the need for clients using different versions of different schemas in order to implement their applications. So now you know what to do. How do you do it? For that, I'd like to introduce Miguel. Apigee is a highly extensible and customizable platform with great out-of-the-box features, but there are ways to do other things with it. There's Feuer support for healthcare, there's open banking support for financial services companies, and much more, including GraphQL. With that, I'd like to hand over to Miguel. Miguel, take it away.
All right, so first, let's take a look at an overview of the architecture for this demo. On the left side, we have the Apigee developer portal. And in this developer portal, we have the GraphQL playground embedded within the Apigee developer portal. Next, we have the Apigee API gateway, which is fronting Apollo GraphQL. The Apollo GraphQL server is running in Cloud Run. Within the Apollo GraphQL server, there are also a couple of Apigee plugins that send login and tracing data to GCP. Throughout this demo, we're going to dive into each of these components left to right, one at a time. Let's go ahead and get started. First, let's go and take a look at the developer portal. I already have navigated to the developer portal, so let me go to that tab. Here in the developer portal, this is an Apigee Drupal developer portal that has the GraphQL playground embedded. As you can see here, the playground has already been loaded with an endpoint. This endpoint is the Apigee endpoint that fronts the Apollo GraphQL server. We can take a quick look at the docs tab and we'll see the schema that has been loaded into the playground. All right, let's take a look at it. So this schema represents a company that aggregates trail and lift data for ski resorts. So you can see the top level, we have a ski resort data type, and within the ski resort type, we have different information, and some of that information is trails and lift data. Let me show you a quick diagram that shows this schema. You can see here the resort type, and then under that we have trails and lift data. This is the reading or the query schema. There's also a mutation schema, but I won't show that yet. We'll go that later. So let's head back into the developer portal. Let's run a query that lists all the resorts that are available. So we do a query, list all resorts, and for each resort, let's just pull the name of the resort. And we can run this query, and you can see that we have 3 resorts, Kirkwood, Sierra Tahoe, and Heavenly. Now, if I keep trying to run this query multiple times, let's see what happens. You can see, and we had an error. So we have a rate limit error. This is Apigee that has detected that the client has sent too many requests over a certain period of time. So within Apigee, it's running a quota policy, and that policy rejected the call. So how do we get around this? One way to get around this is to actually get an API key and maybe make a call using a specific API key that has a higher entitlement in terms of calls per minute. So let's do that. Notice I'm not even logged in. Apigee rejected the call based on the client IP address and the number of calls originating from that address. So let's go ahead and log in so that we can create an app and get an API key. I already have an account that I created earlier, so let me just log in with that account. So now let's go ahead and create an app. And I'm going to call my app Peter app. And for this app, I'm going to select the GraphQL Bronze API product. This product has a higher entitlement so that I will be able to make calls without being worried so much about the number of calls per minute. All right, so my app has been created. Now I should be able to get the API key from this app. Let's grab the API key and secret for this app. All right, so here we have the new app that was created, and we'll grab the API key or the consumer key and the consumer secret. I'm going to open the GraphQL Playground in a new tab. That way I can just copy paste these values over there. So let me copy the consumer key. All right, so back here in the GraphQL Playground, let's use the consumer key and the consumer secret. So in Apigee, we have modified the GraphQL Playground slightly to make this experience a little bit smoother. So on the top right here, you can see Client Credentials button. So this is a widget that we have added expressly for this purpose. So let's click on here and let's add the client ID. All right, so we have client ID. Next, let's grab the client secret or the consumer secret. And let's go back in here and paste the consumer secret. And you can also see the scopes that are going to be requested. So basically, this is a proper OAuth flow that we're going to be doing. And we're going to be requesting a token that has introspection and reading or reader scopes. So let's get a token. All right, great. So we have a token. So this token came from Apigee itself. And we can take a look at the token itself, and you can see there's some details about the token, and we have the reader scope. So let's go ahead and close this. Now we should be able to run this query multiple times with this token that we just got using the API key. Let's do that. And you can see now that we're not hitting this limit that we were hitting earlier. Cool. So we're not getting that error anymore. So you can see that since we got the API key and we were able to get a token with a proper scope, that error is gone away. What if we want to do something else now? Let's say we want to add a resort to the current data set. Let's take a look at the schema for the mutations. So if we look at mutations, we have a resource mutation, and if we want to create a resort, in this case, this follows more like a almost like a REST CRUD example: create, delete, update. Intuitively, to create a resort, we will go here into the create resort mutation. And you can see that the create resort mutation takes a create resort input. And this is the data that we're going to be passing in to create a new resort. So let's go ahead and do this. One more thing. So notice that it's documented here that in order to run the resource mutation, you need the site admin scope. You'll see how that comes into play in a second. So let's try to run a mutation for creating a resort. Create new resort, and this is going to be the resource mutation. And under the resource mutation, we're going to go on create. And for create, we're going to pass an input. And this input, we're going to give the name of the resort. Let's say this is going to be North Star. And the base elevation, let's say, is 6,300 feet. And the summit elevation, 8,500 feet. And after we create the new resort, let's pull up the ID of the resort that was just created and the name of the resort. All right, so this should be good. Let's try run this now. And we got an error. So again, this is Apigee returning the error. This is not coming from the backend GraphQL server. Apigee is saying, hey, you're not authorized to create a resort. You don't have access to these fields. So you cannot access the resource mutation and the resource mutation create. So these fields are not authorized with the current key or the current token that I have. So how do we make this work? Obviously, the token that we have right now, let's take a look at it again. This token, it only has these two scopes, introspection and reader scopes. And in order to be able to run this mutation, according to the documentation, we need this site admin scope. So in order to get a token that has a site admin scope, we need to have access to an API product that offers that scope, or that offers those scopes. So let's take a look back at the API products. So if we go back into the app that we created earlier, this app was subscribed to the GraphQL Bronze product. This GraphQL Bronze product does not offer the site admin scope. In order to get the site admin scope, I need access to another product. So I have already created another app called Shredder, and this app has access to GraphQL Platinum. So the GraphQL Platinum product gives us a higher level of access in terms of different part of the schema that we can access. And this product has already been approved and it's enabled for this app. So let's switch to use the key and secret for this other app. All right, let's grab the consumer key and bring it over here. Next, let's get the secret. And finally, let's change the scope to site admin. So this scope will give us access to a different part of the schema. Now let's get a token, and we have a new token. Hopefully now with this new token, we should be able to make the call to create a new resort. Let's do that. Great, and you can see the call is successful, and we can verify that it was successful by listing all the resorts again. So let's do that. All right, so we get our resorts, and let's get the name of all the resorts. And you can see here, Northstar has been created. All right, so you have seen two important key functionalities that Apigee is adding on top of the existing GraphQL backend. First, you saw throttling, and then you saw field level authorization. Now, let's peer behind the curtain to see how that is done within Apigee. Let me bring up the architecture diagram just to remind you where we are. So we're looking so far at the developer portal. Next, we're going to look at the Apigee API gateway to see how those throttling and field level authorization were actually happening. All right, let's head over to the Apigee UI. Great. So here, this is a proxy that was driving the entire experience you've seen so far. The first policies that you can see here, these are course level authorization policies. It's just saying, hey, do you even have a valid token that allows you to call this API? Then we have the throttling policy or the quota policy that checks, are you allowed to make the number of calls you're making so far? And finally, we have the fine-grained authorization policy that checks whether or not the current token has the correct level of access for the fields within the specific query or the specific mutation that's being sent to the GraphQL server. Let's take a look at the quota policy. You can see this policy has been configured with a default value of 5 calls per minute. This is in fact the behavior you saw initially when I was making those first calls to get the list of resources. Later, once I created an app and subscribed my app to the Bronze or the GraphQL Bronze API product, I was able to make more calls. And that's defined outside. That's defined in the product itself. So if we look at the GraphQL Bronze product, you can see that the GraphQL Bronze product has defined a quota of 30 requests per minute. Next, let's look at how the fine-grained authorization was working. Here, you can see in the GraphQL Bronze product that I have defined a set of allowed OAuth scopes. These are introspection and reader scope. I also have the other product, which is the GraphQL Platinum, which has an even bigger set of OAuth scopes. In addition to introspection and reader scope, it's got resort admin, resort manager, and site admin. Remember, we used site admin when we went to create the new resort. So this is great. You can see how you're able to manage both the SLA, the throttling level, and the fine-grained authorization to the GraphQL endpoint, all within Apigee using the concept of API products. Now, you may be asking yourself, how are these scopes being translated to individual fields in the GraphQL schema? Let's take a look at that next. All right, so how do we go from a scope to an actual set of fields or an entitlement? To do that, we have stored the configuration of a mapping of scopes to fields in Apigee itself. And let's take a look at that. This is in an Apigee KVM, key value map. So this is stored in here, and let me open it so you can see. For each scope, I have listed here the entitlement or the set of fields that this scope is allowed to access. And in the case of earlier, we're using the site admin scope, and you can see the site admin has access to mutation resource and mutation resource wildcard, which means that if you have the site admin scope, your token is allowed to access any of these types within the GraphQL schema. All right, so let's go back to the proxy and put it all together. So the first policy that runs is the authorization policy. This is course level authorization. It just checks, hey, do you have a token? And once you have that token, it extracts the basically the scopes that you have associated with that token. It also verifies that this token is allowed to access the proxy itself. It doesn't check individual fields, but it extracts the scopes. Then you have the quota policy that checks, hey, are you still within your allowed limits? And then you have the fine-grained authorization policy. For this fine-grained authorization policy, it basically takes the scope that was associated with the token that came in and converts that scope to a set of entitlements or a set of fields, and it checks that the set of entitlements or the set of fields that are allowed for this token satisfy all the fields that came in the specific query or the specific mutation. And if that's the case, then Apigee will go ahead and let the call through and go to the GraphQL backend. And if not, then Apigee returns an error. Next, let's take a look at what happens after Apigee sends the call over to the actual GraphQL backend server. Let me bring up the architecture diagram again. So the call came in from the developer portal, arrived at the Apigee API gateway. Apigee checked the call for security, course level, and fine-grained field level authorization. It also did throttling checks, and then it sent the call over to the actual Apollo GraphQL server. This server, I have it running in GCP, in Cloud Run, and within here, I have the Apollo server. I have added a couple of Apigee plugins that allow you to send data over to GCP Cloud Login and also to Cloud Tracing. And this data is sent asynchronously in batches, so it does not affect the runtime of the main call itself. Let's hop over to the Google Cloud Console and take a look at some of this data. Here, I have the GCP log viewer, and I'm showing the create new resort mutation that we ran earlier. You can see the actual payload for the mutation is being logged, as well as the timestamp for this mutation. All right, let's go over to the trace. Great. So here, each of these dots represent an individual query or mutation that has been sent to the Apollo GraphQL server. And I have selected already here the mutation that was run to create the North Star resort. You can see the trace information shows how long it took to fetch each individual field in that mutation. This is all data that is produced by Apollo itself and is being shipped off to Google Cloud and shown here in the trace view. So this gives you a good view of the individual timing and tracing information for specific queries. What if you want more trend information or overtime information of the data itself? Apigee collects analytics information for every request that comes through the system. So let's go over and take a look at some of that. Let me switch to Apigee Analytics. So here I have created a custom report in Apigee that takes a look at the individual fields that were fetched for queries over time and also mutations as they pass through the Apigee gateway. And this data has been enhanced with the timing information provided by Apollo itself. You can see that it shows different fields, how many times each of those fields have been fetched, and the average response time that it takes to retrieve those fields. You can also create other types of reports with this data. It's not just limited to fields. You can do different aggregations, maybe per client, which clients are requesting what kinds of fields. In fact, let's drill down into one of these. So you can see here that the different apps, for example, the Product Playground app is requesting some traffic over here, and then the Peter app, which is the one I created, also has some traffic for the resource name. Hopefully, this gives you an idea of how powerful both combining Apigee analytics with the cloud tracing data and the cloud logging data can be to enhance the information that you can get for the traffic going through your GraphQL server. Well, folks, that's it for the demo. Now, let me hand it back to you, David.
That was awesome, Miguel. Thank you. So what are 3 things you can do today with GraphQL? If you use Apigee to manage your APIs, you're one step closer to your destination. Go download the GraphQL GitHub sample and play with it. We'd love to hear your feedback. If you're not an Apigee user, go to apigee.com, try out the free version of Apigee, use GraphQL or don't, and do cool stuff. We'd love to hear about that as well. And lastly, if you're a GraphQL user and you want to learn about the best place to build APIs, Google Cloud's Cloud Run is an awesome backend for your GraphQL serverless applications. Definitely check it out. Thank you so much for your time today, and we look forward to seeing you and hearing from you throughout the week.